Hey, this is Bill Trombley from Trombley Tool in East Troy, Wisconsin. Today's video is on how to move an existing tipped edge. If you're in metal shaping long enough, you'll come across this problem. So what we have here is a propeller spinner for a 3-bladed propeller, and it has this tipped edge around the blade opening. And I was asked if I could take and move this edge 1/8 of an inch to make this opening a little bit wider. And the reason why is on the propeller blade there's a de-icing boot, and it's electric, and there's a series of wires that go down the blade shank, and it was touching on the spinner. So they said, could you move it? So now for me to do this, I have to do it consistently 3 times. So it has to be an accurate process. And when we get into doing projects like this, it's very easy to think of, well, that somehow you're going to have to get this into a machine, right? And you guys know in my shop I have all sorts of machine capability as far as power hammer and Eckhold machines and English wheel and whatever. But here, this process can be done with hand tools. And so what this video is it'll show you how to do it easy and very accurately. So the first step is make a paper pattern of the existing cutout. So here at this back edge was the back edge of the propeller spinner, because they have to be repeatable. And basically I took a magnets and stuck the piece of paper onto the surface and traced that existing outline. Once I had it, that existing outline, I marked a new series of lines that were 1/8 of an inch away and corrected the contour so it would flow into the existing tipped edge, because here this portion of the tipped edge is still staying the same. I'm only correcting it in this back area here. So once I did that, put sandbags in here so that this thing doesn't fall off the workbench. Another thing that I've used in the past, and this really helps a lot, is this blanket here. I don't know if they sell this stuff anymore. It's kind of rubber and it's perforated. You'd find it in woodworking stores. And it's great for this kind of stuff. It protects the surface finish as best as possible. Makes it so that this is, in essence, sitting on a rubber mat, so it isn't squirting around on the tabletop. Once I take my paper pattern and I finalize the geometry, I get what I want, I transferred that to a piece of aluminum. To get the aluminum to fit, this is a compound curve panel here, low crown panel, but nonetheless a compound curve. I run my piece, my template piece, through the power hammer. And you know, this took a few minutes. This isn't a lot of time invested into making this. I would scribe a line from my paper pattern, cut it close out with a tin snip, sand to the line, debird it, run through the power hammer, create the compound curve, verify what I wanted. And then on here, I punched in this hole. That hole and then this edge. And what that is in the spinner is a hole, 3/16, and this edge. And what I wanted was that the template can go onto the spinner in the exact same spot on all 3 blade openings. To hold it in place, a cleco through the hole, and then I have these here. These are called cleco clamps. It was not in my clamp video. I forgot I had them. Had them in the drawer. Spring loaded, basically like a C-clamp. And they work pretty good for this kind of stuff here. So clamp my pattern now into place. So now the pattern is going in the exact same spot on all 3 blade openings. You can see like that. And the pattern has the correct geometry to it. I have a fine line Sharpie. Draw my line in there the way I wanted. But this is what makes this process a little bit different than the way you might normally think about it. So this piece of aluminum is 50 thousandths thick, 2024 aluminum, so it's pretty tough stuff. And that piece alone is now my new hammer form. So instead of making up a bunch of blocks that all have out of hardwood that have a compound curve to try to get to match this piece of or this original propeller spinner contour, 3D printing something, trying to get this into a machine, it's a lot of work for what little of the issue is. So what I do is, and I'll move the camera over here like this, just to make it easier. I'm right-handed, and that way I can swing the hammer. Is with this aluminum strip in place, and I have my blue magic marker line, I can make sure that the hammer form, this aluminum strip, doesn't move. Right? It lines up with my Sharpie line that is in there. I feel like I'm always bent over, like I don't have this tripod high enough. So now, as you guys know, I use a lot of plastic tooling and aluminum. I don't like tool marks. Customers don't like tool marks. We can't go just grinding tool marks out. It actually, a heavy tool mark from a steel on steel hammer hit to a dolly actually is changing the grain structure, and so if you watched any of my earlier videos, you can see I use plastic tooling all the time. These here are body dollies that are plastic. Pat Brubaker Imperial Willing Machine in Hastings, Nebraska sells these things. I use these a lot. This is a standard track dolly or T dolly. He has this style here. And they're great, right? No stretch is going to occur from this. This here is the hammer that I use the most. It's made by Dagger Tools, who's in Michigan. And I got his teardrop mallets, and I use those a lot. But this is the one that I prefer the most. And the benefit is what I'm going to be doing is with these 2 clamps on there in the Cleco holding my pattern in place, is now what that is doing is it's reinforcing the edge where the new tip needs to occur. So materials will take the path of least resistance. And it's important to think about, and it's true when we do a lot of different shaping, is to remember that it will take the path of least resistance. So because of this doubler being here, and now this material being so much thicker, and then a harder grade of aluminum, 2024 is pretty strong stuff. It's up in the 68,000 psi tensile strength range, I think. It's in the 60,000s. It's very tough material. And the edge, because of the way that cut is put in there, that you're trying to take and bend my template this way. It's not going to want to do it. It's going to want to keep that radius that I ground on there to stay. The plastic tooling is I'm just supporting that. I'm keeping my hammer form in place, and I'm supporting it right where I want the tip to occur. So I can easily go along. Let me see if I can get you to maybe see in here a little bit better. Like this. I can easily go along. and clean it up. You can see here, this is already looking much better. And to verify my pattern doesn't move, because I got 2 points of reference. I have the hole with the Cleco in it, and this edge has to line up with the back of the spinner. So that way I know this is not sliding around on the surface. Different dolly, because I got this clamp here, and I can move this out of the way a little bit. Like that. And come in here and clean up this last little bit. Now, you got to get inside here and swing up on this. Now you can see, and I already had this one roughed out. I have the other 2 blade openings already done, but you can see how tight the tip is now to the new profile, this having the new profile on it. And it gives us the finished look like that. You can actually see where the paint is in the corner there, where it didn't sand out of the corner, and it's moved up now 1/8 of an inch. Like how that is. So you can see where the original tip line was there, and now where the new tip line is down there. 1/8 of an inch isn't a lot, but it's enough to solve the problem that we have with this project. And dealing with tipped edges, like I said earlier, is something that us as metal shapers come across. And sometimes even with all the best layout, once the panels get built, it's slightly off and you have to adjust it. So when you have to adjust it, consider this process here. Making a simple pattern out of a piece of sheet metal that's thicker. You know, if you guys are doing this 19 gauge steel, get some 16 gauge steel. Run it through your power hammer or your English wheel, make it a compound curve, and clamp it on and use that as the hammer form. It doesn't have to be a massive wood block or something where it's, picture me now taking this piece of wood and trying to bandsaw this all out and carving it and sanding it and everything else for 3 blade openings. And this will actually break down, right? The piece of wood, if you hit it hard enough, you'll start radiusing the edge off and everything. Where this aluminum strip here won't. So it holds its shape and it keeps it so you get a nice, clean, consistent result all 3 times. And that's what we're looking for with this particular project. So hope that makes sense and is something that you guys can utilize. Just remember, because you have all of the tools and equipment in the shop, understanding how to metal shape with hand tools is hugely critical, because you can take a project like this and make it extremely complex, or you can make it super easy. And easy makes high quality parts too. So hope it makes sense. Have a good day. Thanks. Bye.